So what we're going to do is we're going to develop long division for polynomials. And just like numbers, it's important to put things in the right order. For example, are these two numbers the same? No, because one has the 7 first, the other one has the 3 first, and the order is important. Same thing with polynomials when we go to divide them. Even though you're allowed to write a polynomial in whatever order you want, the first thing that we're going to do as a setup for long division is we're always going to write them in order from the largest degree to smallest degree. And by degree, that's looking at the exponent. So in this one, we have x cubed, that would have a degree of 2, x squared has a degree of, x cubed has a degree of 3, x squared has a degree of 2, x has a degree of 1, and any constant we would say has a degree of 0. Now, this doesn't happen in this case because we go from degree 3, degree 2, degree 1, degree 0. Every degree is present in our example. But what we're going to do as far as setting up our long division, if something was missing, if there was no x squared, we'd put a 0x squared in just to hold that place. You do that with regular numbers. What this really means is you have 7 hundreds, 0 tens, and 5 ones. That 0 is important because if you, we have 0 tens, let's just not write it, that means something totally different. So that's how we're going to set it up. We write our long division like this, what we're dividing by, and then here, now I'm going to write it in order. So just like long division with regular numbers, the process looks as follows. You look at your first term. In this case, it's a 2x cubed. What would I have to multiply x minus 1 by to get a 2x cubed? I'd have to multiply by a 2x squared. So the first thing you're going to write is 2x squared on the top. And we write it above the x squared column just to hold things in place. And then we multiply 2x squared times x minus 1, just like you did with regular long division with numbers. And when I multiply 2x squared times x minus 1, I'm going to get 2x cubed, and 2x squared times a minus 1, minus 2x squared. In regular long division with numbers, you then subtract it. So we're going to do the same thing with polynomials. We're going to put this in brackets and subtract it. While 2x cubed minus 2x cubed will be 0. But 3x squared minus a negative 2x squared will give us 5x squared. And the other numbers you can just bring down, because you're basically subtracting nothing from those columns, so they would stay that way. I'm going to switch colors, because now we're going to just repeat this process over and over again until we can't multiply something by x to cancel something out. So now, our new biggest number is the 5x squared. What would I have to multiply x minus 1 by to get 5x squared? 5x. So now we go through the same process. I figured out that it's 5x. I then multiply the 5x times the x minus 1. 5x squared minus 5x. Put brackets around and subtract. This is 0. Negative 2 minus a negative 5 is plus 3. And bring down the 5. So now what we did in the red was exactly the same process that we did in the green. So I'll switch colors again. Now my biggest number is 3x. What could I multiply x minus 1 by to get 3x? A 3. 3 times x is 3x. 3 times minus 1 is minus 3. Put it in brackets and subtract. 3x minus 3x is 0. 5 minus a negative 3 is 8. No more x's left. That last number is going to be your remainder. It's a remainder of 8. Often in these questions, they're going to ask you to write a division statement. Division statement looks like this. Your polynomial, that's what the P stands for, equals what you divided by, your divisor, times your quotient, what you were dividing, plus your remainder. So your quotient is the answer that you get, and then there's a remainder in the end. So our polynomial here would have been 2x cubed plus 3x squared minus 2x plus 5. It supposedly equals, our divisor is x minus 1. The quotient, or the answer that we got, was 2x squared plus 5x plus 3. And then our remainder was another plus 8. If you wanted to, you can multiply that out and you would find out if you were right or if you were wrong, because they should be equal. One thing that I like to do just as a check, when I do minus 1 times plus 3, what do I get? If I just multiply these ones, negative 3. If I add my 8, what do I get? Plus 5. Does that match up with there? Yes. So at least I know that my remainder is right based on the numbers I have there. I might have made other mistakes, but as far as a check goes, that seems plausible that that should be right. Okay? Questions you can do for this one are number 3, A, C, and D, and number 5.